next up, we are plugging in what? 3. So I get 3 divided by 3 squared gives us minus 4 gives us 5. So we get 3 over the square root of 5. Yes? So we just took our derivative with our chain rule, simplified a little bit, and then plugged in 3. What does the next part ask us to do? Find the inverse. So this is part A. This will be part B. How do I find an inverse? That would be if they were perpendicular. Like if I have a function, think back to like algebra 2 and pre-calculus. How do we find the inverse function? What do you mean by flip the signs?
Well, like the opposite of like what it's doing to the number, I guess.
Okay, so like yes, there are things that are opposites. So like a square root is the inverse of x squared. Addition is the inverse of subtraction. Agreed. But like if I have a combination of those things, how do I find the actual inverse function? No. This is before we learned calculus. So if our inverse functions undo each other, yes? That means this stuff has to be flipped, or the opposite of each other. Which is why we flip our x's and y's and solve for y. Yes? No? Does that sound familiar? Okay, so how do I solve for y here?
Square both sides.
Okay. And then?
Subtract 4.
Not
Or
quite.
add 4.
There you go. And lastly?
Square root both sides.
Okay, what do we have to put on there? Okay. But because our square root here is only positive, we will also only choose the positive one here. How do we represent an inverse function? How do we notate the inverse of f?
Would be
Do you remember what that looks like? It is the negative one. Yeah, it's like a little exponent of a negative one. So we say the inverse of f is the square root of x squared plus 4. Yes, no, maybe? Now that we've reminded ourselves on how we actually find inverses. Okay, then what's the last part ask us to do?
find the derivative.
Find the derivative of the
Inverse.
inverse and
Evaluated at square root 5.
okay, so I have the derivative of the inverse of x. So again, what are we going to have to use for this?
Chain
Chain rule. Again, x squared plus 4 can be rewritten to the
1/2.
1/2 power. So it's going to be a very similar derivative. So we get 1/2 x squared plus 4 to the negative 1/2 power times, what's the derivative of the inside? 2x again. So again, my 2 and my 1/2 reduce to 1, and we get a square root of x squared plus 4 on the bottom. And then what are we plugging in?
Square root 5.
So what are we going to have on top?
Square root 5.
Okay. What is the square root of 5 squared?
5.
Just 5, right? And then plus 4 gives us 9, and the square root of 9 is 3. So what is the relationship between my original derivative and my inverse derivative? They're reciprocals, okay. Did I plug in the same thing to get those reciprocals? No, okay. How did I choose the square root of 5? Like why does, like not like here. Like obviously that's in the problem. Why did I choose the square root of 5 when writing the problem? Because what? No, that's just like by chance. It won't always be that way. It just happened to be that there's a square root of 5 in there. But other ideas?
Because we chose it.
Yeah, but like how did I choose it to make sure that these two things were reciprocals of one another? Do we think that that will always be the case that they're reciprocals of one another? If inverses are related to each other, right, does it make sense that their derivatives would also be related to each other?
Yeah.
Yes, okay. So they will. They will be reciprocals of one another. But we also have to figure out what is this relationship between the two values that we plugged in. Yes? Like how do we know that they have to be reciprocals of one another by like what we plug in? What do we think? So is there any type of relationship between the 3 and the square root of 5? There is. So how did we find our inverse?
You said. By switching the x and y values? Yeah.
Yeah, we set it equal to y and we flipped our x's and y values. Yes? Okay. So my x value for my function was what? 3. We plugged in 3, yes?
Mm-hmm.
What's the y value for that? If I plug it into my original function.
Oh. Square root of 5.
Okay. And if two things are inverses and I flip all of the x's and y's, does that include I also flipped all of my points as well?
Mm-hmm.
Yeah. So then that means that for my inverse function, the square root of 5 would be my x and 3 would be my y. It's like whatever is an x value for my inverse function is a y value for my original function. Yes or maybe. And that's going to be important for us. Because most of the time, when we're asked to find the derivative of an inverse function, we don't want to have to do this step. Yes? Because 1, taking inverses takes a while. And 2, some of our functions we can't find inverses of. So basically we want to take out this middle part, and we just want to use what we know about our original function and its derivative to be able to just kind of skip to this last step. Or there. Okay. So now we get a nice, fun definition. So let f of b equal a, then the derivative of the inverse at a equals 1 divided by the derivative of your original function at b. Because again, what is an x value for my inverse? I need to find the corresponding y value for my original function. The other way that I think it's on your foldable. So you can see it like that. Like if we just define g to be the inverse, then we don't have to have quite as much inverse notation. The other way that you can see it is the derivative of the inverse of x equals 1 divided by f of f inverse of x. which is just, basically this is doing this part, is that I need to find the associated y value and plug that in to our f. Or sorry, to our f prime on bottom. I tend to not use this notation as much because it gets a little confusing. So, but you might see it every once in a while, like in your book, or if you're looking up something online, that is what they're getting it from. Ready to look at an example? Listen to me. Alright. So it says, given the following, find f inverse derivative of 5. So looking at what they give us, do they give us any information on f inverse? No. Do they give us information on f though? Yes. Which is important. So remind me again, an x value for my f inverse becomes a what type of value for my f? The y value. Yes? And do we know what value gives us a y value of 5 for my original function?
3.
3. So that means that we know we're looking for f prime at 3. Do they give us f prime at 3? Yeah. So we get 1 over 7 halves, which is also 2 sevenths. And that's our answer. Again, the biggest thing that we have to remember is that x values for our inverse are our y values for our original function. I'm going to say it a lot because that's usually the thing that people forget. And they just plug in the number instead. Okay, let's look at a table one. Alright, so I give you again some information about f, some information about f prime. We want to find f inverse, the derivative, at 1. Yes? Okay. But is this 1 going to be my x value? So I come over to the 1 and I look at that derivative. No. Why not?
Because that's the 1.
Well, 1 needs to be my y value for f. Yes? So I'm not looking for 1 in my x's, I'm looking for 1 in my y values, or my f of x's. Are we all with me there? Because again, we're looking at, for f inverse, for f inverse, for me to plug in 1, okay, I'm going to try and get out some number. That's what I'm trying to plug in. But again, we don't have any information about f inverse, we only have information about f. So in order for us to still be able to utilize f, we have to flip our thinking. This would be the y value for f, and we need to figure out what the x value of that would be. Which in this case is what? Yeah, so my 1 here is the y value here. Okay. So then I'm plugging in my -1 here. Now what is the derivative of f at -1? Okay, but then I'm taking 1 divided by -1/5, so we just get -5. Yeah. Now, a really common mistake is people see the 1, they come to the 1 column, and they say that it's -6. Okay? But remember, this x is for my inverse, which means it's a y for my original. So, which column am I using for my zeros. This time I'm going to have a 0 as an x value.
Why? Is it the f of x?
Yes, but like which column am I using?
The fourth one?
Yeah, 1, 2, 3, 4, this one?
Yeah.
Yeah, the 1 column, yeah. Because that's what gives me a y value of 0 now. So that we can plug in an x value of 1. And f prime of 1 is
-1.
okay, so then if I take the reciprocal of that, we get just -6. Just no baby. So not a super hard process as long as you remember to flip your x's and y's. So we looked at function notation, we looked at table notation. Now we're going to look at equations. So again, this one is simple enough that you could technically find the inverse if you really wanted to. However, we're going to practice our notation with not finding the inverse. So remind me, okay, our x values for our inverses are our what values for our original function? Y values, okay, which means that 2 is the what value for my original function?
Right value.
The y value, okay? So if we want to figure out what we need to plug in here, I have to find the x value that gives me 2. So we set our original function equal to whatever that value is. And we just solve. So how do I solve for x?
Square themselves.
Cool. And then,
Subtract 1.
so I get x equals
3.
3. So I'm plugging in 3. Now, what do we also need? Derivative, right? I need g prime. Well, like the rest, we should be able to find g prime here. This is technically x plus 1 to the 1/2 power, which means our derivative is 1/2 times x plus 1 to the negative 1/2 power. What's the derivative of the inside? 1. That's nice. We don't have to multiply by anything. And then what are we plugging in? 2? 3. Okay. So 3 plus 1 gives us 4. Square root of 4 gives us 2. So we get 1/4. Which means that my answer overall is 4. Yes, no baby. So, what questions do we have about inverse? You ready to try it with our favorite types of functions? Trig functions, yay! Which means that we might have to remember back to our unit circle days. So especially now, for those of you that have me and Mrs. Bennett said, the unit circle is not going away. Really, it really hasn't gone away. We're still going to use it today. Alright, I don't know what that's supposed to do. So I'm looking for the derivative of the inverse of f at the square root of 3 over 2. So on this one, if I wanted to say find the inverse and take the derivative of that, what is the inverse of cosine? No, that's the derivative. What's the
Secant?
inverse? That's the reciprocal.
Negative secant.
No. Nope. Nope. Y'all are forgetting a whole class of trig functions that we have. So remember, like on your calculator, when you click the second button first, and then you click your trig function?
The inverse.
Inverse trig, right? Inverse cosine, or we also call them arc cosine, right? Do we have derivatives for our inverse trig functions?
Yeah.
Not yet. We'll get them Wednesday. But we can still do this without it, okay? Which is why we're going to use stuff about our f instead. So this is going to be 1 over f prime of, am I putting a square root of 3 over 2 there? No, because this is an x value for my inverse, which means that it becomes a y value for my original. So here's where we're through a little bit of thinking. Where does cosine of x equal square root of 3 over 2? We should know this one. In ratings, please.
Pi over 6.
Pi over 6. Yes? So remember our like left-handed trig, cosine square root 3 over 2. Now, is there any other places where cosine is square root of 3 over 2?
11 pi over 6.
Yes, so in our fourth quadrant it will also be. Is there any more than that? In our first rotation, right? Is there technically an infinite amount of times that cosine equals square root of 3 over 2? Yeah. Do they give us any helpful information though?
That's to be less than pi, but more than 0.
Okay, so is my fourth quadrant going to fit that? No. So we only end up using the pi over 6, which is why if you have a trig function, they're going to have to give you that. Okay? Which means we're plugging in pi over 6 here. What else do we need now? In order to plug in. The derivative. What is the derivative of f?
Negative.
Now we get negative cosine. What is cosine of pi over 6? Well,
1/2.
sine is the square root of, sorry, if that should be sine.
Negative sine.
Negative sine. If cosine is the square root of 3 over 2, then our sine should be the 1/2. Yes? There we go. Got writing too fast. Yes?
Yes.
Okay. Which means this is going to be 1 over 2, but negative. So it's going to equal what overall?
Negative 2.
And that's right. So this is a very valid non-calculator active question. Okay? The AP test and I assume that you have enough trig knowledge, okay, to be able to work your way backwards to pi over 6. If you don't, then we need to maybe be busting out some like note cards with the unit circle on them, or watch some videos, because you need to at least have your first quadrant of your unit circle memorized. Okay. Now there will be some questions where it's calculator active and you don't get a nice pretty number, and that's fine. But like in this case, we should know enough information to get here. All right, we got one last one. What type of function do we have here?
Quadratic.
Is it a what?
Quadratic.
No.
Is it a quadratic?
Cubed.
It's cubed, so it's a
Cube.
no, just a cubic.
It's a trinomial.
It is a trinomial, right? But it's a cubic trinomial, yes. So would this one be very fun to try and find the inverse of by hand? No. So this is one of the ones that I was saying, even if they give you the equation, there are some that we would not find the inverse of that, because if I switch an x and a y, now I have y cubed plus 2y, and that we can't solve for that. So that's why we have to use our formula this time. So we know that the derivative of the inverse of 2 is going to equal 1 over the derivative of f at, what do we have to do to find that inside number?
You get 2 for y.
Cool. So then how am I going to solve that?
factor out the x on the right.
You can only factor it out from two of them, and I can only factor things when we're equal to 0. Okay, if I subtract 2, what do we get?
X cubed plus 2x minus 3.
Alright. Now, does that factor?
No.
Does it factor using any standard techniques that we know of? No, like our AC method, the quadratic formula, completing the square, all of those work for quadratics, and that is not a quadratic. Yes? Do we remember our other method? My pre-calc kids actually happen to be doing it right now. It's using synthetic division. But we're gonna do the shorthand version. Okay. So remember that your zeros of a polynomial function have to be p of x. Are we all okay with p of x stands for polynomial function? Okay. Have to be of the form plus or minus c divided by L, where factors of the constant are c and factors of leading coefficient are L. So in order for it to be a real number, 0, I have to be able to take sum of the factors of this and divide it by the factors of that. Those are the only options that we have for our rational zeros. Yes? No maybe.
Yeah.
So, what are our options in this problem for C? What are the factors of C?
-1, 3.
So we're going to do plus or minus all of them, so we really only care about the numbers.
1 and 3.
1 and 3. Are we all okay with that? Yes? What's my leading coefficient?
1.
1. What are the factors of 1?
1.
1. So that means that my options are basically plus or minus 1 or plus or minus 3. Yes, no, maybe. Now, last year you would have then used synthetic division to decide which one of those actually works. We're not going to do that because that takes too much time. We're just going to plug and chug. Okay. So I'm going to pick my first number. What number do we want to try first?
1.
1. 1 cubed is plus 2. 3 plus 2 is 3, right? Minus 3 is
0.
0. We win. So x does indeed equal 1. And if this is a non-calculator active question, you're going to get a number that works like that, where it's like 1 or 3, something like that. Okay? Now, calculator active, it doesn't have to be a nice number. How would I get my x value if this was calculator active?
You could use decimals.
Yeah, or graphing calculator, but what am I looking for on either one of those?
The x-intercepts.
Yeah, so wherever my x, right, is hit on my x-axis, that would be the solution here, yes? And then that's then what we're plugging into the derivative, okay? In this case, you don't need that because it's an iceberg enough. What's our derivative here?
What?
Derivative of our original function.
3x squared plus 2.
Okay, and so then what is f prime of 1? 5. So then our final answer is
1.
yippee. What questions do we have there? How do we feel about inverse functions so far?
Amazing.
That's good. Basically, it's just remembering your formulas and remembering to flip your x's and y's. It's the base thing there. Alright, that's all we've got.